Continuing in chapter 10, we're going to be doing page 328 and going through page 332 right now. We're going to skip over section 10.3 cycloalkanes. We'll come back to those. We're going to go over isomers right now. An isomer, now there's two different types of isomers. Isomers are two compounds that have the same molecular formula, but they're in different molecular structures. For instance, you can have a structural isomer. Structural isomers, they have the same chemical formula, but their atoms are bonded in different orders. For instance, C5H12 could be arranged in this way. And if you look, we have 5 carbons consecutively. This is page 12 of my notes. 5 carbons consecutively. Everywhere you see these little dashes like that, that means that there's a hydrogen on the end. I just don't want to write hydrogen over and over and over. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's still C5H12. And if you look at this, this is actually pentane. This over here, we have 5 carbons still. 3 would be on here, 1 on there, 3 on there, 2 on there, and 3 on there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's still C5H12, but they look completely different. And it also will be named different. This one is actually 2-methyl butane. Okay? Because this would be the longest consecutive chain. This would be your substituent of a methyl group, and it's on the second carbon. This one down here, we have a carbon kind of in a T-shaped, I guess you could say, tetrahedral shaped. Down here, this carbon, you're going to have 3 on it, 3 on here, 3 on here, 3 on here. There's 4 of them times 3, that's still 12. And this one actually would be named, this or this could be your longest parent carbon chain. You would have 2 methyl groups attached to it. So you would have 2,2-dimethylpropane, because they're all single bonded still. So that's how structural isomers are different. They still contain the same components, but structurally they're different. They're bonded in different ways. Now, the other type of isomer you can have, they're stereoisomers. Now, stereoisomers, there's pretty much 2 different types. There's geometric stereoisomers. These are different arranged groups around a double bond. Now, the main thing you see with this in the book is cis versus trans. And don't let this confuse you. Cis and trans are very easy to recognize. A cis, all that's going to indicate is that you have 2 of your same things on the same side of that double bond. For instance, there is a methyl group here and a methyl group here. Hydrogen here, hydrogen here. These are on the same side, the top of the double bond. If the CH3s were on the same side of the bottom of the double bond, that still would be a cis. Now, trans, for instance, trans are going to be opposite of one another. You're going to have a CH3 on top and a CH3 on the bottom. And most of the examples you're going to be giving will look most of the time like this around a double bond. Occasionally you might have aromatic cis or trans, but most of them you're going to have in this linear form. So this would be a trans because they're opposite of each other. Now, the second type of stereoisomer is going to be an optical isomer. Now, optical, this should be pretty easy to remember. I gave you this example with carbon in the middle and X, Y, Z is around it or whatever. W, X, Y, Z is around it. If you look at them in my notes on page 13, this and this are the same thing. They're just mirrored images of each other. So this is going to be an optical mirror image, that's easy to remember, of an isomer. So it's the same thing, it's just flipped in space. It's a flipped version of your original equation. So that's going to be an optical isomer. So if you look on my notes, still on page 13, at the bottom there, it gives you 3 options, A, B, and C. And if you notice, they're circled in different colors. The first option that you're given this shows that this is going to be a geometric isomer because it's flipped at the double bond. So you see how up top here on the left-hand side there's an F, and on the right-hand side there's an F up top, and there's an H on the bottom and an H on the bottom. So even though it's not the exact same molecular formula, there's still a fluoro on top of each side, and there's still a hydrogen on the bottom of each side. So that's geometric because it's like a cis versus a trans thing. That would be a cis because they're both on top. The second option gives you, this is going to be an optical isomer of each other. The third option, it just shows that the F there, that's a structural isomer of one another from one side to the other. And that's pretty much the isomers that you can find throughout this chapter. They give you some other examples